So this is an example of how to complete a half-life problem. First of all, when you look at this problem, you can see that there's lots of numbers and sometimes that can be confusing. So the first thing I'm going to look at is what's important and what's not important. This is the name of the element that is undergoing decay. I don't need to do anything with that number. It's zinc 71. That's simply telling me that the weight of this zinc isotope is 71 atomic mass units. However, I do have some other numbers that are important to look at. And those numbers would be this, which indicates a half-life of the zinc. It says half-life is 2.4 minutes. And an amount is also important. It's telling me that I'm starting with 100 grams of zinc. It's asking me how many grams are left after 7.2 minutes have passed. So that's the information that I would want in blue. The way I could set this problem up is I create my table and I write half-life, I write time, and in this case time is in minutes, and I write amount, and in this example it's in grams. Those are my units. I always begin half-life with 0 and time with 0 because that's when you count, you always start with 0, 1, 2, 3. The amount is what they're giving me as 100 grams. That's what I'm starting with. Half-life means that after 2.4 minutes, half of my amount will be decayed. So this becomes 50. Okay? It's important to remember that the amount is always divided by 2. Or if you're working backwards, you would have to multiply it by 2. And I'll give you an example of that a little bit later. Time is always added. Alright, so for my next half-life, I'm going to take 2.4 plus 2.4 and come up with 4.8. Half of 50 is 25. Third half-life, again, I'm going to add on 2.4. So that'll be 7.2 minutes. Okay? And then half of 25, is 12.5. That's my answer. They want to know how many grams are going to be left after 7.2 minutes. So I reach 7.2 minutes. This is the amount that I'm left with, and I would write that 1.25 grams, not 125 grams, is what I would be left with after 3 half-lives have passed. Okay, this is another example of a half-life problem, and again I'm going to circle the items that are non-essential in red and underline the things that are important in blue. It's telling me that I'm working with palladium 100. That is just the name of the element that I'm working with, so that 100 has nothing to do with anything. But it does tell me that the half-life of it is 4 days. It's also telling me that 12 days have gone by and that I have a sample that has a mass of 4 grams at 12 days. So these two are connected. What's the starting mass? So this is an example where I'm going to be working backwards. And again, I'm going to set my problem up with half-life, time, and amount. Here again, my amount is in grams, my time is in days. Okay. Starting half-life with 0, time with 0, my amount is a question mark. I know that my half-life is 4 days. All right. I know that I am left with, I have to go down to 12 days to figure out 4, 8, 12. So again, remember, for time, you're adding the time. So here I just added 4 plus 4 is 8, 8 plus 4 is 12. So I know that I'm left with 4 grams at 12 days. And so that would mean it's 3 half-lives. I'm going to go backwards. So again, I'm going to times this by 2. I'm going to say 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. My answer is 32 grams. Okay. So I would just kind of write that off to the side, circle it, and show my work. Okay, here's another example, and this will be the last example that I show you. Again, let's look at the numbers that are non-essential. So you've got radon 222, that's just the name of the isotope that we're working with. The numbers that are important are the amount, which is 64 grams, and the half-life, which is in days, and a final amount. So they're asking me for time in this question. They want to know how long, so that's time, how long it'll take for a sample of 64 grams of radon to decay to 8 grams. So again, I'm going to build my table, and sometimes it helps if you do this on lined paper, especially if you're going to be doing a lot, but for the sake of this, I'm just going to be writing it on my iPad. Amount is in grams, time is in days, and remember, you always start with 0 for half-life and 0 for time, and the full amount, which is 64 grams. We know that one half-life is 3.8 days, so I'm going to just kind of write that down. And I know that by definition, half-life means that half of the product decays. So half of 64 is 32. So I just kind of divide that by 2. For my second half-life, again, I'm going to add 3.8. So that will be 8 and 8 is 16. I'm going to put down the 6, sorry, and carry the 1, 7.6. Half of 32 is 16, and half of 16 is 8. And if I add another 3.8, I'm going to be coming with 11.4, and that'll be my third half-life. So again, in this question, they were not asking for an amount. This is what was given. This is what I was looking for. So my answer is 11.4 days. And that's it.